Welcome to this video. This is a walkthrough, the example about using pipelines and column transform. So in this example, we're going to use a data set that is called insurance, where the dependent variable is charges, right? So it's like how much someone is going to be charged based on, some numeric and categorical variables. So we have age, the gender, BMI, body mass index, number of children, if the person is smoker or not, the region, and of course the Y variable charges. Okay, so we're getting the data set from this website. The libraries that we're using, the typical pandas, NumPy, scikit-learn. So from scikit-learn, we're getting pretty much everything, the pipelines, everything for the pre-processing, the standard scaler, the one-hot encoder, column transformer, and also for the modeling part, decision tree regressor. All right. So once we get our data, we can get like a descriptive analysis just to get an idea of our variables to perform an EDA. The dataset initially doesn't have missing data, but even there is no missing data in this dataset, it's important to prepare our models in the future, our pipelines, to know how to handle missing data. It's important to create a rule what to do if there is a missing data, because you may get an error if you don't define these rules. All right, so as you can see here, this data set has different data types, numeric and categorical. So we need to keep that in mind when we are designing our pipeline. Okay, so let's get started with the pipeline. So the first thing is you need to separate our data, and you need to create an X matrix. This is for the features or predictive variables, and we need a vector, the Y. That's for the dependent variable. That's the variable that we want to predict. So we get everything except charges for X, and of course we just pick charges for the dependent variable. We define the numeric and the categorical variables. So for numeric columns, we have age, BMI, and children. For categorical, we have sex, smoker, and region. Okay? So once we have this clear, now we can start creating our pipeline. So please notice that this pipeline, it doesn't have data initially. It's just like an instructor that will know how to, where you are defining how to process each step. But again, we will use it later with the data. So the first step, it's an imputer. This is for the missing values. So remember that we have numeric and categorical. So we are going to define two strategies. So since I'm going to kind of in the same step, I'm going to handle differently the two data types. That's why I'm using here a column transformer. Remember that the column transformer does that. It takes the data frame, but it splits the data set in numerical categorical to apply a process, like a separate process to each column. So for the numeric variables, we use the simple imputer. This is for, you can get this from scikit-learn, and the strategy is median, the median value. So if there is a missing value, we're going to replace it with the median, but that only applies to the numeric column that we define here, right, initially. Okay, so similar idea for the categorical variables. So we impute, now this is categorical impute. We use the same simple imputer, but the strategy, of course, is different. Here we use the most frequent value, right? But that only will apply to categorical variables. So this column transformer is gonna, separate the columns in numeric and categorical and apply these two imputations, right? And then it's gonna merge together. It's gonna concatenate again the columns, right, to pass it to the next step of the pipeline. So the second step, which we're defining here, it's the transformation. So in the transformation, we are gonna do some encoding for the categorical variables, and we're gonna standardize the numeric variables. So since we have two separate procedures, again, we need here a column transformer. Now, if just for a moment, if in a different problem, we just have, let's say, numeric variables, then there is no need of the column transformer. You just do the simple the imputation and the transformation, and there is no need for the column transformer. We're using it because we have different data types. All right, so in the second step, we apply to the numeric variables, we use standardization. This is the standard scalar that we have here, only apply to the numeric columns. For the categorical columns, we use a one-hot encoding using the one-hot encoder that it's again provided by scikit-learn and applied to the categorical columns. So same idea. Once these two data types, like the different columns that belong to each subset is transformed, then the column transformer is again going to concatenate them right into a single object that is going to be passed to the final step. So we have imputation, transformation, and then we have a regression model, a regressor. In this specific pipeline, we're defining a decision tree regressor, right? We can add here, if you want, some of the parameters. So at this point, we define the pipeline, the complete pipeline. So we say, okay, we will call it model. And that pipeline has 3 steps. The impute, where we're going to use it, where we're going to use the imputer that we define here initially, right? This one. Then the second step, transform. So we use the transformer that we define here. And the last one, we call it like regression. And we're using here a decision tree regressor. So now that we have created our pipeline for the decision tree regressor, we can now test it. So it's important that we split our data and we only enter initially the training data because we're just training. Remember, the testing is going to be saved only to check the performance of the model at the end. Okay, so we use the train test split. 20% to the test and 80%, of course, for training. So now we fit our model. Remember that this model is the pipeline. So when you do model.fit, what we're doing is we're calling the pipeline, the complete pipeline. So this data that we're feeding here, the X train and the Y train, they have the original units, the original structure when we read the file. But once we apply the fit here, of this pipeline, it will take these data frames and it's going to apply the 3 steps. It's going to first impute if there is missing data. It's going to transform the variables. The numeric is going to standardize them, and the categorical is going to create, it's going to do the one-hot encoding. And since we said that it's a decision tree regressor, the last step, then of course, once these variables are transformed, then it's going to train a model. It's going to train a tree regressor, and we can test it. We can check the performance of this model here. This is for the predictions. We can use the same pipeline for prediction, which is nice. And here we can see the performance. So the R-square in new data. So the R-score is for the using the test set. Because the R-square for the training set, you need to see it because just to evaluate whether we have overfitting or not, but the one that really matters at the end is the performance in new data, in the test set. So it's 0.75 is decent. That depends, of course, of the baseline or comparison with our algorithms, but for now, let's say it's decent. Now, let's see how it looks, the complete pipeline. You can visualize how it looks. So this is our pipeline. It has 3 steps. The first step is the imputation, then the transformation, and then the decision tree regressor. So in the imputation, we have a column transformer. That's why we have these 2 elements here in parallel. So for the numeric variable, the simple imputer using the median, we can see a strategy here if you click. For categorical, we're using the most frequent, the mode value. And for the transformation, numeric variables, we're standardizing and we're using a one-hot encoding. And finally, we train the model with a decision tree regressor. So this is just the first part, but we can use this pipeline for the hyperparameter, like when we're tuning the hyperparameter tuning. So we can fit the grid search, right? Same idea with cross validation. Once you have this pipeline, you can feed a cross validation the function, so you can evaluate the model, like over different splits and check the performance. And at the end, you can create a pipeline with the final model. I mean, once you have picked which is the algorithm that you're going to use, which is the specific model with the like the best possible hyperparameters, then you create that pipeline, like with the pre-processing, the imputation, transformation, and with the model that you chose during all the analysis. So it's only for prediction, right? Once you completed your training and your analysis, your evaluation. All right. This is the example. You can find it on Brightspace or below this video. I'll see you in our next lecture.